Hello everyone, I'm Danny Valdez, and today I'll be teaching you guys how to do the Lewis structure for dicarbon hexahydride, which is carbon 2, hydrogen 6, as presented right there. And to start off, we're going to go ahead and calculate the number of bonds this given Lewis structure will have. And to do that, let's get the number of valence electrons the carbon element has. And that usually has 4 valence electrons, and hydrogen has 1 valence electron. Now let's take into consideration how many of each given element there are. There are 2 carbon atoms, so that'll give us 8 valence electrons, and 6 hydrogen atoms, which is 6 valence electrons. Next, we'll go ahead and add both of these numbers up, and that'll give us 14. Next, we'll proceed to divide this number by 2, and that'll give us 7. We're going to subtract any unshared pairs, and in this equation we have none. So our number of bonds will be 7. Now, before actually doing the Lewis structure, let's go ahead and give ourselves the Lewis structures of each of these elements. The Lewis structure for carbon is like that. The reason it doesn't have another one in the s orbital is because it lost it to the p orbital. And the Lewis structure for hydrogen is like that, because it only has 1 valence electron. Now let's go ahead and start to assemble our actual Lewis structure for dicarbon hexahydride. Now that'll actually be, before any of that, I need to determine which atom will be our center atom, and I'm going to go ahead and choose the carbon atoms because those have the most open spaces. So let's go ahead and assemble that now. And as you guys can see, there's already 1 bond there, so we only need 6 more. And let's go ahead and link up all those hydrogens to each of these unshared electrons. As of now, we've used 4. Let's go ahead and use the last 2. And as you guys can see, all these have bonds. Let's go ahead and link them up. And let's go ahead and count up how many bonds we have. We have 1, 2, 3, 4, 5, 6, 7. So we have completed the number of bonds, and that is what our final Lewis structure will look like. Thank you. Hello everyone, I will be teaching you guys how to do the Lewis structure for iodate or IO3 with the negative charge of 1. So let's draw this out. So IO3 -1, which is also known as iodate. So first, let's go ahead and do some math and calculate the total number of valence electrons. And iodine has 7 valence electrons. And each oxygen atom has 6, but there are 3, so that makes it 18 valence electrons. And we have a charge here, so we're going to go ahead and add another one. And that gives us 26 valence electrons. So by doing that, we should continue this to determine the number of bonds that this given Lewis structure will have. So let's go ahead and divide this number by 2. That'll give us 13 valence electrons. And next, let's determine how many unshared pairs iodine has. Iodine has 7. So, number of unshared pairs, 1, 2, 3. So there are 3 there. 3. And oxygen has 6. So it's 1, 2, 3, 4, 5. It has 2, so 6, 6. So it'll be minus 9. Minus 9. Let me just check if I did that correct. So we got 1. Okay, yeah, so we did that correct. Now we're going to go ahead and get 4 bonds that this Lewis structure will have. So we're going to strive towards getting 4 bonds. So let's go ahead and build our Lewis structure. I'm going to go ahead and put iodine in the middle because as we'll just put that in the middle because it has the least electronegativity and the most open spaces. So iodine goes in the middle. And let's surround it with oxygens. And we're going to go ahead and use 26 of these valence electrons to bond them. And these are filling their octets. So, given that we used all 26 valence electrons and all octets are satisfied, but this iodine's octet can be expanded, so let's go ahead and do that. So we're going to go ahead and cancel these out and these out, and move them here so they get double bonded, and that'll then give us a Lewis structure that looks like this. And there's one bond there. I'll go ahead and draw this one out again because it's not too neat. So it should look something like that. We'll go ahead and draw it nicer. Didn't really come out that nice. Okay, so let's go ahead and draw this out one more time. So iodine's going to be in the middle. Surround it with oxygen. Now we have two bonds here. Boom, boom. Then we have two valence electrons surrounding this uppermost one, 2, 2, 4, 4. And next we have something that should look like this. So this, given we were supposed to have 4, but given that charge, this has 5, so we're gonna go ahead and put this in brackets and write a charge of -1. Thank you very much, and I hope I taught you how to do the Lewis structure for iodate or IO3 with a charge of -1. Thank you very much, and have a great day. Goodbye.